So I think the other day we kind of went over some proofs about equalities, some proofs about segments. Sorry, not proofs necessarily, but properties. So here we're going to go over properties and theorems and proofs around angles. So um, when we're talking about, we're given a statement like angle A equals 90 degrees, we're talking about the definition of a right angle, which is where right angles are literally 90 degrees. When we're talking about definition of complementary angles, it's going to be a statement that's given where we're talking about two angles added together, the measures of those angles added together, and they equal 90 degrees. Similarly, for supplementary angles. So we want to be careful about the distinction between a definition and a theorem. So theorems do not talk about specific measures. They talk about the angles in general. If you look, the little m is gone from these theorems. Now, definition of perpendicular, they might say that line L is perpendicular to line M, therefore two right angles are formed. And similarly with the definition of angle bisectors, they might say line L is an angle bisector of angle MGC, therefore two congruent angles are formed, right? So what it might look like is these two angles, right? And here's this line bisecting the angles. Let's go find us a line here. And here's this line here, right? Bisecting these angles, right? And most notably, what we would find is they'd have these two arc marks here to show that these two angles are equal. So if this one's 30, then this one's 30, and the whole angle itself is 60 degrees. So that's how that works. And remember these theorems, we're talking about angles in general. Vertical angles, they're always congruent. Angle addition postulates, essentially where part plus part equals the whole. And then we have the definition of congruent angles, which is basically if they're equal, then they're congruent. If they're congruent, then they're equal. So reflexive property just equals itself. Symmetric, no matter which way you turn it, there's same meaning. Intransitive is just transference of the property. Now, we're going to get started here on these properties. So keep in mind that I already know these properties. All right, but some key information we want to be highlighting here is when we see this measure here, we're talking more than likely about a definition. Okay, so it says if angle A is a right angle, then the measure of angle A equals 90 degrees. So here we're talking about the definition. So we use DEF of a right, and I'm going to use a symbol for angle. Okay. It says if angle X is supplementary to angle Y, and if angle X is supplementary to angle Z, then Y is congruent to angle Z. Ooh. So are we talking about congruence or are we talking about supplementary angles? So we're going to actually leave this blank. Leave that blank. I don't want you to confuse our supplementary theorems with transitive property. But this is actually, it's actually substitution. and it's unfair that it was presented this way, but it's substitution. It says if this is true, what kind of angles are these? These are vertical angles, so we're referring to a form of the vertical angles theorem. So we don't always get a statement, we might get a diagram. If the measure of P, oh my gosh, we're looking at definitions here, plus the measure of Q equals 90 degrees, then these are complementary. So this is a definition of complementary. If angle M and angle N form a right angle, then these angles are complementary. So we're talking about a theorem because there's no measure there. So I hope you see the difference between definitions and theorems. It says given this object, which shows two perpendicular lines, if L is perpendicular M, line M, then angle 1 is a right angle. So this is definition of perpendicular. I use a symbol for perpendicular there. If L is complementary to angle M, and N is complementary to angle M, then angle, I'm going to write that in, angle L is congruent to angle N. So this is an example of substitution. If angle W and X are supplementary, then the measures are equal to 180. So this is definition of supplementary. Okay. If A and B form a linear pair, then A and B are supplementary. So this is definition, is this linear pair theorem or definition of linear pair. If angle W and X are complementary, then the measures equal 90. This is definition of complementary angles. If a measure of angle R equals measure of angle S, then they are congruent. So this is definition of congruent angles. Are congruents with angles. Okay. Says given this object, the part plus the part equals the whole. So this is referencing the angle addition postulate. Okay. And the next part is proofs. So I'm going to leave it there and make a second video for proofs.